Okay, so in the last lecture we have discussed the polymerization, what are polymers, and how addition polymers are formed. I've discussed this thing with you that there are two different types of polymers: addition polymers and condensation polymers, and how addition polymers form from the alkenes. Monomers for addition polymers are alkenes, right? This is what we discussed in the last lecture, and this is how polyethene would form from ethene molecules, right? The double bond would break. This double bond would break due to high temperature and pressure, and large number of ethene molecules will connect to each other and they would form polyethene. And this is the chemical equation for the addition polymerization, right? So this is what we discussed in the last lecture. And now in today's lecture, we will discuss few more examples of addition polymers, and we will discuss a comparison of the properties of monomers and addition polymers. But before discussing all those things, you have to understand one more thing, and that is that the addition polymers or polymers, they do not have fixed size. Polymers or polymeric chains do not have fixed size, right? For example, let's say if we have one polymeric chain of polyethene, let's say this is polyethene, right? So we could have a polymeric chain made up of 10 molecules, or let's say 100 molecules of ethene. We could have a polymeric chain of 200 molecules. We could have a polymeric chain of 500 or 10,000. Okay, so that means the number of monomers present in a polymeric chain is not fixed. And when we have large number of those polymeric chains made up of different number of monomers, so these are large number of polymeric chains, they are all tangled up with each other, and it forms plastic sheets. This is plastic bag made up of polyethene, right? So this is how plastic bags form. A large number of polymeric chains, they get tangled up with each other and it forms plastic, right? And next we have to discuss the a comparison of the properties of monomer and the addition polymer. There are few properties which we have to discuss which comes in exam, so you must have an idea that how to compare those properties for the monomer and the polymer which would form from that monomer, right? So let's suppose if we have the monomer which we have is ethene, right? And polymer would be polyethene. So we will discuss few properties, and this comparison, it comes in paper as well. So you must have a fair idea of how to compare these properties. So first we will discuss the molecular formula of the polymer and the monomer. So the molecular formula of ethene is C2H4. Everyone knew this thing, or you can write it in that way as well, CH2 double bond CH2. In case of polyethene, double bond breaks, and now we have CH2 single bond CH2 bracket N, where N is not fixed, right? And on both sides we have this bond. So this is the molecular formula of polyethene. So the molecular formula is different for both monomer and polymer. And then the next property is empirical formula. Now the empirical formula, it comes from simplifying the molecular formula. So if we simplify the molecular formula, if we simplify this formula, we get CH2. And if we simplify this formula, we get CH2 as well. So that means the empirical formula is same for both monomer and the polymer, right? So this is same. So this comes in P1 and P2 a lot of time. And next is the relative molecular mass. Next property is relative molecular mass. So if you calculate the relative molecular mass for ethene, that is 12 into 2 plus 4 hydrogen atoms. So this is 28, right? And the molecular formula of polyethene, because this is made up of large number of ethene molecules, so it is around 15,000 or greater than that, right? So this is not a fixed number, but most of the time we made a polymeric chain which has a molecular mass of around 15,000 or greater than that, right? So this would be the molecular mass of the monomer. So there is a huge difference between the molecular mass of the monomer and the polymer. Now the next property is the number of atoms in one molecule. Number of atoms in one molecule. These are basically few features, not the properties which we are discussing here, but these are silent features of the monomers and the polymer. Right, so the number of atoms present in one molecule of ethene, 2 carbon atoms plus 4 hydrogen atoms. So this would be 6 atoms. In total, we have 6 atoms. And if we calculate the number of atoms for a molecular mass of 15,000, it is around at least 300 or greater than that. So you don't have to memorize it, but you just have, you must have an idea of this difference, that how large addition polymer is as compared to its monomer, right? And next thing is very important, that is the melting point of both the monomer and the addition polymer. So if we compare the melting point, right? So because the monomer is very small as compared to the polymer, so that means the melting point would be very low for ethene. For ethene, it is around minus 185 degrees centigrade. But for polyethene, because this is made up of large number of atoms, large number of molecules, so it is much higher than ethene. Much higher than ethene, because it would be difficult to break such large number of bonds, right? So this is much higher than ethene. And then state at the room temperature, so obviously state of the polymer would be solid, state at RTP, room temperature and pressure. Ethene is gas at room temperature and pressure, and polyethene is solid at room temperature and pressure. And if we react, one more thing which comes most frequently in past papers is the reaction of the addition polymer and the monomer with aqueous bromine. Reaction with aqueous bromine, right? Because this is a test for the unsaturation. I hope everyone knew this thing, that this is the test for unsaturation, right? So if bromine decolorizes, that means alkene is present or unsaturated compound is present. So with ethene, because it contains double bond, when we react it with aqueous bromine, it decolorizes. Bromine decolorizes, right? Because it reacts and it decolorizes. But with polyethene, because there are no double bonds, so that means no reaction, no color change. So this is a clear indication that now we do not have an unsaturated compound, right? And in the last, the reaction of both the the reaction of both the monomer and the polymer with air, combustion. So if we discuss the combustion in air, so ethene, when it will react with oxygen present in air, it burns to give carbon dioxide and water, burns to give CO2 and water. That means combustion occurs. And polyethene, this would also, because this is also a hydrocarbon, so it also burns to give carbon dioxide and water. So this is similar for both the monomer and the polymer, right? So these are few things which we have to compare between the monomer and the polymer. And next, we will discuss few more examples of the addition polymers and their uses. You might get some questions in P1 related to the uses of addition polymers. So as we have discussed about the polyethene, first let's just talk about the polyethene. So this is the polyethene molecule, right? And polyethene, this is used to make, polyethene is used to make Plastic bags. This is used to make plastic bags, plastic bottles, buckets, and pipes. Right, so these are few uses of polyethylene. This is polyethylene. Put a bracket and N. Okay, next, if we have another monomer, let's just talk about some other addition polymers. Let's say if I have this monomer C double bond CH2 HHHCl. Now this is known as chloroethene. This is the monomer and it is known as chloroethene because it has double bond, two carbon atoms and a chlorine atom present. So this is known as chloroethene. So if we have large number of chloroethene, what would happen? Let's say if we have large number of chloroethene molecules. So if we have large number of chloroethene molecules, let's suppose this is one chloroethene, then we have another chloroethene, and so these are large number of chloroethene molecules. So if double bond, if it is subjected to high temperature and pressure, the double bonds would break. Double bond breaks, and these chloroethene molecules, they would connect to each other, and it has a Cl group attached. So they would connect to each other, and now we get a large polymeric chain. All right, now one more thing in this structure. If you look at this structure, we have four monomers. We had combined four monomers. So this polymeric chain is made up of four monomers, and you can see that there is a pattern which is repeating itself in this polymeric chain. And the pattern which repeats itself, like let's suppose if I start from here, the CH2, this repeating pattern ends here. This is the pattern which is repeating again and again. Like let's suppose if this is the pattern, again we have the same pattern repeated here, then again we have the same pattern repeated here, again we have the same pattern repeated here. So the pattern which repeats itself again and again in a polymeric chain, this is called repeating unit. So in most of the questions they ask you to identify the repeating unit in the polymeric chain. So this is the repeating unit, right? And if you just in few questions they give you the polymeric chain, and then they'll ask you for the repeating unit and the structure of the monomer. So if you have an addition polymer, then if you have an addition polymer and you just simply find out the repeating unit, and if you draw the repeating unit, just draw to find out the structure of the monomer, just draw the repeating unit as it is. Right, so this is the structure of the repeating unit, and place a double bond between carbon atoms. This would be the structure of your monomer. Right, so if you want to find out the structure of the monomer of an addition polymer from a polymeric chain, so this is very simple. Just identify the repeating unit. Once you have identified the repeating unit, draw the structure and place a double bond between both the carbon atoms. This would be the structure of the monomer, right? And the name of this polymer is polychloroethene. This is known as polychloroethene, also known as polyvinyl chloride, commonly known as polyvinyl chloride or PVC. And this is used to make water pipes, also waterproof plastic sheetings, insulation for electric cables, because addition polymers, they are very good insulators. They do not conduct electricity. So insulation for electric cables. Right, so these are few uses of polychloroethene or polyvinyl chloride. Okay, so these are few examples. Now let's just say if they ask me to draw the structure of polypropene. Let's say if we have to draw the structure of polypropene, right? So polypropene, that means, let's suppose if the question comes that draw the structure of structure of polypropene showing at least 3 repeats, right? So you have to draw the structure of polypropene showing at least 3 repeats. So polypropene is an alkene with 3 carbon atoms, right? This is polypropene 1, 2, 3. Let's say if I place a double bond here, so that means we have 2 hydrogen atoms here, 1 hydrogen atom here, and 3 hydrogen atoms here. So this is the structure of polypropene, and this is the structure of propene, and we have to draw the structure of polypropene. So propene is the monomer of polypropene. Propene is the monomer of polypropene, and we have to draw 3 repeats. So if you look at this structure, you must notice that now we have 3 carbon atoms in our monomer. Previously, we had only 2 carbon atoms. In this case, we have 3 carbon atoms. So what you have to do, you just draw those 2 carbon atoms which have double bond between them, the 2 carbon atoms which have double bond between them horizontally. These are the 2 carbon atoms, these 2 carbon atoms. We have drawn these 2 carbon atoms horizontally, and the third carbon, this one, the third carbon would be shifted either to the bottom or to the top, to the carbon which it is attached, right? Like the third carbon atom I would draw here, CH3, right? And what other group is attached to this carbon atom? We have drawn this CH3, and this is the hydrogen as well. So the hydrogen is on the top. If CH3 you have drawn on the bottom, hydrogen would be on the top. And then this carbon has 2 hydrogen atoms, so these are 2 hydrogen atoms. So this would be the way to draw the monomers of an addition polymer. Now let's draw the polymeric chain made from polypropene. So we have to make 3 repeats. So let's say this is 1. Now I'm not drawing the double bond, I'm just drawing the single bond. So instead of writing this carbon and hydrogen separately, we can also write CH3. So I'm just writing here CH3. On the top we have hydrogen, this hydrogen, and this. So this is one monomer, and then another monomer, CH3H, H, and the third one, because we have to draw 3 repeats, CH3H, H. And because they are connected to each other, so just make a bond between these carbon atoms, this carbon atom, and this is continued on this side and continued on this side. So this is the structure of polypropene. And how will you identify that this is the structure of polypropene? Identify the repeating unit. Your repeat starts from here, and if you notice that it ends at the second carbon atom. Right? In addition polymers, the repeat and always end on the second carbon atom. Now, if you count the number of carbons in your repeat, 1, 2, 3. We have 3 carbon atoms in our repeat. So if we have 3 carbon atoms in our repeat, that means the structure is made up of propene. It is made up of propene. So you must have same number of carbon atoms in your repeat and in your monomer, right? So if you have 3 carbon atoms in your monomer, you must have 3 carbon atoms, 1, 2, 3. 3 carbon atoms in your repeat as well. So this would be the structure of polypropene. Now, if they'll ask me to draw the structure of, let's solve another example. Suppose if they want me to draw the structure of polybutene. So that means in total we have 4 carbon atoms, 1, 2, 3, 4, and butene means double bond at the second carbon atom. So this is carbon number 1, carbon number 2. So this is the double bond at carbon number 2. Now, while drawing the structure of the polymer, what we have to do, we just draw the carbon atoms which have double bonds. We draw them horizontally, and this carbon atom, which is carbon number 1, the carbon number 1 is attached to carbon number 2, right? So we would draw carbon number 1 either on the top, CH3, or at the bottom. You can draw either on the top or the bottom. And this is carbon number 3, carbon number 4. Carbon number 4 would be attached to carbon number 3 either on top or bottom. So let's say if I draw it here, so this is also but2ene. Now you can just simply draw the structure of the polymer. Let's say 1, 2, 3, 3 repeats, a CH3 on the top, a CH3 at the bottom, CH3 at the top, CH3 at the bottom, or CH3 at the top, CH3 at the bottom. And then make a bond between these molecules, hydrogens. You have to show the hydrogens as well. So this is the structure of polybutene, showing how many repeats. If you count the first, let's just identify the repeating unit. So the repeats starts from here and it ends here. So this is the repeating unit, and how many carbon atoms we have? 1, 2, 3, 4, right? And second and third carbon atom are placed horizontally, so that means we have double bond between second and third carbon atom. So this is the structure of polybutene. Let's solve another example, and this time we would draw the structure of a polymer and we would identify the structure of the monomer from the polymeric chain. All right, so this is the polymeric chain. We have drawn the polymeric chain here. Now first we have to identify the repeating unit, and you just pause the video and identify the repeating unit by yourself and draw the structure of the monomer and name the monomer, and then watch the video to find out whether you have drawn it correctly or wrong, right? So if I start the repeating unit from this side, so this is the pattern. You just have to take two adjacent carbon atoms in your repeat. So this is the repeating unit. This is the pattern repeating itself again and again. So this is the first repeat, second repeat, and third repeat. So we have 3 repeats drawn here, right? And if I draw the repeating unit separately, so this is the repeat, CH3, CH2, CH3, H, and H. And then we just have to draw the double bond between the horizontal carbon atoms. So now if we count the number of carbon atoms, 1, 2, 3, 4, 5. And if I number the chain, so carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. So we have total 5 carbon atoms and a double bond at carbon number 2. So that means this is, the monomer name is pent-2-ene. All right. So I hope everyone now understand this concept, that how to draw the structure of an addition polymer and how to identify the structure of a monomer from the polymeric chain. Next, in the next lecture, we will discuss few past paper questions on addition polymers, and then we'll start condensation polymerization. All right.